Hi, today's session is on correlation coefficient. About correlation coefficient, we have already learned the theoretical framework. Now, this session is solely dedicated for calculation of correlation coefficient. Now, there are two different ways to calculate correlation coefficient. For this session, we are discussing Karl Pearson's correlation coefficient, right? And in Karl Pearson correlation coefficient also, we are discussing case 1. Now, what is the case 1? Means are in whole number. That means the data which will be given to us, if we take mean, we will get whole numbers. We will not get means in decimals. Right. See, our problem says find the correlation coefficient between advertisement expenditure and profit for the following data, and values for advertisement expenditure and profits are given to us. Now, advertisement expenditure is a variable for the company because every year or every month, whatever time duration they are taking, they can change the amount of expenditure spend on advertisement, right? Similarly, profit is another variable, right? Because every month or every year or every quarter, whatever they are calculating, the value of profit may change, right? So therefore, in your problem, you have two variables. One is called advertisement expenditure, one is called profit. Now, our job is to tell that is there any relationship between advertisement expenditure and profit, right? So correlation coefficient is calculated for bivariate data. That means you will have two values. Here we have two variables. One is advertisement expenditure, one is profit, and correlation establishes a relationship between these two variables. And at the end of the solution, it will help us to comment whether these two variables are related to each other or not. If at all they are related, what type of relationship do they have and what is the degree of relationship, right? So we are commenting on three things. Is there any relationship between these two variables? If it is there, what is the nature of relationship and the degree of relationship between these two variables, right? So we will be using Karl Pearson's correlation coefficient. The formula says R equals to covariance of xy divided by sigma x into sigma y. Now, for covariance of xy, you have to see the lecture on covariance, and for sigma x, sigma y, which is standard deviation, to understand this, you have to again see the lecture of standard deviation. We are not discussing here what is covariance, what is standard deviation. We are only discussing how to calculate correlation coefficient R. Fine. So whatever formula do require to solve this, we have a list here. Sure. So we'll start. I'm naming first given variable as x. So this is my x. Second, which is profit, I'm naming it as y. So this is my y. Fine. See, the case says means are in whole number. So I need to get mean of x. At the same time, I need to get mean of y. So how to get mean? Get the total of this x, right? So if I get the total of this x, this is the total. I'm highlighting it. Similarly, the total of this is 360, right? Now this is our x bar. So I'm calculating x bar equals to total of x is 240. So it is 240 divided by how many observations do we have? 1, 2, 3, 4, 5, 6. So it is 6. So 240 by 6, that means the mean of x is 40. right? Let me come down. Same thing I need to do for y as well. So I'm taking y bar equals to summation of y is 360, right? Total of this, and again we have 6 values. So it is by 6 equals to 60, right? Now see the case means are in whole number and both the means are in whole number. So we can apply this formula, right? Now to apply this formula, the first add a column which will be x minus x bar, right? X minus x bar. Since you will be doing manually, so you need not to copy paste. So x minus x bar. Now see, this is my x, first x, 30, and this is 40. So 30 minus x bar is 40, so it is minus 10. Or let me write it this way. 30 minus, let me write directly. This is 30 minus 40, so it is minus 10. Next x is 44 and x bar is 40, so 44 minus 40 is 4. Similarly, 45 minus 40 is 5, 43 minus 40 is 3, 34 minus 40, it is minus 6, 44 minus 40 is 4, right? So next we need to get square of this. That means we have to add one more column, which is the square of this deviation. Square of this deviation. See, just put it on the side there. Now, square, this is x minus x bar. Next column is x minus x bar whole square. So minus 10 square is 100. 4 square is 16. 5 square is 25. 3 square is 9. 6 square is 36. Perhaps it is minus 6. Minus 6 square is 36. 4 square is 16. Now add it up. So this is our x minus x bar whole square, right? The same activity we need to perform for y as well. So I'm calculating y minus y bar. Now see, this is y, right? So y is 56, whereas y bar is 60. So 56 minus 60 is minus 4. Next, y is 55 minus 60, so it is minus 5. Next, y is 60. Y bar is also 60, so 60 minus 60 is 0. Next is 64 minus 60, that means it is 4. Next, 62 minus 60, so it is 2. Last, 63 minus 60, so it is 3. Right? Next, we need to get the square of y minus y bar. The same activity which we performed for x minus x bar, right? So minus 4 square is 16, minus 5 square is 25, 0 square is 0, 4 square is 16, 2 square is 4, 3 square is 9. Now get the sum of this. So it is 70, right? One more column we need to add, which is x minus x bar, x minus x bar into, it is y minus y bar. So it is y minus y bar. I'll just little. So how to get this? See, this is my x minus x bar and this is my y minus y bar, right? So we need to multiply these two corresponding values. So x minus x bar is minus 10 and y minus y bar is minus 4. So minus 10 into minus 4 is 40. This is 4 and this is minus 5. So it is minus 20. This is 5, this is 0, so it is 0. This is 3, this is 4, so it is 12. This is minus 6 and this is 2, so it is minus 12. This is 4 and this is 3, so it is 12 again, right? And get the sum of this as well. So it is 32, right? Now, let us start solving. See, we know R equals to covariance of xy divided by sigma x and sigma y. So let us first calculate covariance of xy. Covariance of xy. So formula says covariance of xy equals to summation of sigma x minus x bar y minus y bar, right? So summation x minus x bar into y minus y bar. So here is our x minus x bar into y minus y bar and summation is here. So it is 32 divided by n. N is what? N is number of observation. So how many observation you have? 1, 2, 3, 4, 5, 6. So it is divided by 6. Now 32 divided by 6 is 5.33. Now we have to calculate sigma x. So what is our sigma x? Now sigma x, the formula says under root summation x minus x bar whole square. So x minus x bar whole square and summation is here. So it is square root x minus x bar whole square is 202. 202. It's 202 divided by, this is 6 observation, right? So 202 divided by 6 is 33.66. Therefore, square root of 33.66 and find the square root of this. So it is 5.80. It is come down. Now we have sigma y. Sigma y. So sigma y has to be the square root of sigma y minus y bar whole square. This is our y minus y bar. Summation is here. So it is 70 divided by, we have n, that means 6. So it is 70 divided by 6. 70 divided by 6 is 11.66. That means we have square root 11.66 and square root of 11.66 is 3.41. Now see, we are supposed to calculate R, for which we need covariance of xy. We have covariance of xy. We need sigma x, we have sigma x. We need sigma y, we have sigma y. So let us calculate our R equals to covariance of xy is 5.33 divided by sigma x into sigma y, which is equals to 5.8 into 3.41. That means 5.33 divided by 19.778. Right? So this is equals to now 5.33 divided by 19.778 equals to 0.269. On rounding off, it is 0.27. So this is our R. Now, recall in the beginning of the session, I said through correlation coefficient, we give three type of informations. First, whether relationship is existing or not, right? Now see R. Now R is a value, correct? That means relationship is existing. If it is zero, right, instead of any value, if it is zero, then we would have commented that correlation does not exist between x and 5. Now since in our case it is 0.27, so we'll comment correlation exists between advertisement expenditure and profit. Secondly, if it is existing, what is the nature? Now see, the sign of R is positive, right? We have received a positive value. That means these two variables are positively related. These two variables are positively related. Meaning of positively related, if x increases, y will also increase. If x decreases, y will also decrease. That means their movement will be in the similar direction. Lastly, we are supposed to give degree of correlation, which is 0.27, right? So the degree of correlation is 0.27. Fine. So I'll write all the three comments here. First is advertisement expenditure and profits are related to each other. Fine. Secondly, advertisement expenditure and profits are positively related. Third, the degree of correlation between advertisement expenditure and profits is 0.27, right? So what we did, first we identified our x and y. Then for x, we calculated x bar, that is mean. For y, we calculated y bar, which is mean of y. And we checked whether the mean are in whole numbers or not. If it is in whole number, we proceeded further. We found out x minus x bar. We found out y minus y bar. Then for x minus x bar, we get the square. For y minus y bar also, we get the square. Then lastly, we found out x minus x bar into y minus y bar. Then with the help of the given formula, we calculated covariance of xy, we calculated sigma x, we calculated sigma y, and finally we put all the values in the formula of correlation coefficient given by Karl Pearson, and we calculated R equals to 0.27. Right? Hope you have understood the concept. Right? For any further query, Mail me on earth.sarkar86 at gmail.com. Thank you.